Today we are going to talk about our last quadrilateral, which is a kite. So a kite is a quadrilateral with two pairs of consecutive congruent sides with opposite sides that are not parallel nor congruent. So instead of having opposite sides that are parallel and congruent, like we saw in parallelograms, we actually have consecutive congruent sides. So sides that are next to each other or are adjacent are congruent. In this specific kite, we have side KI is congruent to side KE, and side IT is congruent to side ET. In addition, it has some properties of its own, so its diagonals are perpendicular, which means they intersect to form a right angle. So if I draw the diagonals, we know that they intersect to form a right angle. The opposite angles between the non-congruent sides are congruent. So if we look at the angles that are between non-congruent sides, that would be angle I and angle E. Those two angles are congruent. We cannot say that angle K and angle T are congruent because they are not between non-congruent sides. Those two angles, K and T, are between congruent sides. So we do not know that they are congruent. Lastly, we know that the longer diagonal bisects the shorter diagonal. So diagonal KT cuts diagonal IE in half, so we can say from I to the intersection is congruent to the intersection to E. And we know that it also bisects the angles that it intersects. So the long diagonal bisects angle K. It cuts angle K in half, and it also cuts angle T in half, making the two smaller angles congruent to one another. If we take a look at example 1, we want to find the measures of angle 1 and angle 2. We know that the angles between non-congruent sides are congruent. So we know that the measure of angle 1 is equal to 110 degrees. To find the measure of angle 2, we know that all four angles in a quadrilateral must add up to 360 degrees. So we can add up 110 plus 110 plus 98. And we get 318 degrees. So the measure of angle 2 is going to be equal to 360 minus 318, which is equal to 42 degrees. So the measure of angle 2 is 42 degrees. For example 2, we want to solve for x. Again, we know that the diagonals are perpendicular, so they intersect to form a right angle. So we can set 6x plus 6 equal to 90. We're going to subtract 6 from both sides. 6x equals 84. And then we're going to divide by 6. So x equals 14. For example 3, we want to find the measure of angle G. Again, we know that opposite angles between non-congruent sides are congruent. So angle E and angle G are congruent in this case. To solve for one of them, we first have to solve for the sum of the two. So we can add 150 and 90, which is equal to 240. We know that all four angles must add up to 360. So we can do 360 minus 240, and we get 120 degrees. So now we know that the measure of angle E plus the measure of angle G must be equal to 120 degrees. To find just one of them, In this case, we want to find the measure of angle G. Because those two angles are congruent, we're going to take 120 and divide by 2, and we get 60 degrees. So the measure of angle G is 60 degrees, and the measure of angle E would also be 60 degrees. For number 4, we know that the longer diagonal bisects the shorter diagonal. So in this case, HJ is congruent to JF. So I'm going to set 1/10 x minus 1 equal to 9. I'm going to add 1 to both sides. We get 1/10 x equals 10. Now I have to multiply by 10 on both sides. Oops. So I have x equals 100. For example 5, we know that the diagonals are perpendicular. So if we just take a look at this right triangle here, right, we know that all three angles have to add up to 180 degrees. So we have 90 plus 4x plus 2x plus 6 is equal to 180 degrees. We can ignore the 3x plus 6 because it's not really relevant to us. So we have 6x plus 96 is equal to 180. I'm going to subtract 96 from 180, and I get 84. Then I'm going to divide both sides by 6, and x is equal to 14. For example 6, again, I'm just going to focus on this triangle first to solve for x. I know that all three angles must add up to 180, so I have 38 plus 17x plus 1 plus 3x plus 1 is equal to 180. So I get 20x plus 40 equals 180 when I combine like terms. I'm going to subtract 40 from both sides. So 20x equals 140, and then I'm going to divide by 20, and x is equal to 7. Now I also know that opposite angles between non-congruent sides are congruent. So this blue angle here is going to be congruent to 2y. So I can say 2y is equal to 17x plus 1. I just solved for x, so I can plug that into my equation. 2y equals 17 times 7 plus 1. 2y equals 119 plus 1. So 2y equals 120. I'm going to divide by 2 on both sides, and y equals 60. For number 7, we want to find the perimeter of the kite. In order to do that, we need to find these side lengths here. And we know that consecutive sides are congruent. So the purple sides are congruent and our green sides are congruent. We also know that the diagonals are perpendicular. So we actually have 4 right triangles within our kite. When we know 2 sides of a right triangle and we are trying to solve for the third, we can use the Pythagorean theorem. So to solve for the green sides, we have 3 squared plus 3 squared equals c squared. 9 plus 9 equals c squared. So c squared equals 18. Take the square root of both sides. C equals the square root of 9 times the square root of 2. We could break down the square root of 18. So C equals 3 radical 2. So our green side lengths are both 3 radical 2. Now for our purple side, we have 5 squared plus 3 squared equals C squared. 25 plus 9 equals C squared. So we have C squared equals 34. We're going to take the square root of both sides, and we get C equals the square root of 34. We can't simplify that any further. So we know our purple side lengths are both the square root of 34. Now to find our perimeter, we're just going to add up all 4 side lengths. So 3 radical 2 plus 3 radical 2 plus radical 34 plus radical 34. Here we can add like terms together. So we have 3 radical 2 plus 3 radical 2 is 6 radical 2. And then we have radical 34 plus radical 34 is 2 radical 34. So our perimeter is 6 radical 2 plus 2 radical 34 centimeters. We cannot combine those terms any further. All right, lastly, we want to talk about the area of a kite. So if a kite has an area of a square units and 2 diagonals of d1 and d2, then the area is equal to diagonal 1 times diagonal 2 divided by 2. So we're going to multiply one diagonal by the other diagonal and then divide by 2. So if we take a look at example 1, the length of one diagonal is 6 meters. The length of the other diagonal is 13 meters. So our area is equal to 6 times 13 divided by 2. 6 times 13 is 78, and 78 divided by 2 is 39. Our units here are meters squared because we are talking about area. All right, last example here. One diagonal is 16 meters. Our second diagonal, we know this piece here is 7 centimeters, but we have to find this piece here. So again, we can use the Pythagorean theorem to find that missing side. We have 10 squared. 10 is our hypotenuse here. So we have x squared plus 8 squared equals 10 squared. X squared plus 64 equals 100. X squared equals 36. And the square root of 36 is 6. So this missing side length here is 6. So our second diagonal measures 13 centimeters. So to find our area, we have 16 times 13 divided by 2. 16 times 13 is 208. Divided by 2 is 104 centimeters squared.